Hi, I'm Matt Jackson, and this is Next Level Carpentry. You know, you don't get professional results on woodworking projects by accident, but by using a planned approach and a few pro tips, they're entirely possible. So if you want professional results on projects with sharp mitered corners, like these short cove sections for the box newel project I'm working on, stick around and I'll show you how I made them so you can too. I'm in the thick of it making the coved parts for the box newels. I got most of these pieces cut with double 45s on the back, but I thought I'd better stop at this stage and kind of explain the process. In the last video I showed the process for making these coves in all these parts, and the next step is to put a 45-degree angle on all the sides of all the pieces so I can put them together to make the basis for these box newels. And I'm just about done ripping the bevels on the back, but I wanted to stop long enough to explain the process I'm using to make sure all these parts are as accurate as they need to be to produce consistent sized pieces so that the cove base parts of the newels fit with the center waist section on all of them. If there's any kind of discrepancy between them, then I've got to do a lot of fussing and fitting to get the newel post together in the end, and I don't want to do that. So here's the process I use for getting accurately sized pieces with double bevels on them. Because of the nature of cutting something with a sharp 45-degree miter on both sides creates problems, because when the miter is sharp enough for a tight glue joint, the long point of that wants to slip under the rip fence. If there's any discrepancy there whatsoever and that sharp point of the miter slides under the fence, or it's not consistent on every pass, the pieces are going to be tapered and it'll just end up like a mess. So the method I use is to rip the pieces on a table saw with a small flat spot on the side. I hope this shows up in the camera. There's just a small flat spot on the side, and there's one on each side, so that that small 1/16 of an inch shoulder on the piece rides up against the fence when I cut one side and when I cut the other side. If you've worked with sharp 45-degree angle cuts on a table saw, you know what I'm talking about. If you haven't, take my word for it and watch how this process goes so you'll know what to do if you end up with this kind of fight on your hands. So I start the process with layout, and I've already ripped these pieces to a consistent width, but I determine that width by taking the final width of the part, which is going to be 4.5 inches, and then I leave an extra 1/16 of an inch on each side. So for a 4.5 inch wide piece, I start out with 4 5/8 inches, which is what I ripped all these pieces to. That way the sharp point of the miter will be 1/16 inch in on each side. And the thing that a table saw is good at is ripping pieces to an accurate width with two parallel edges. There again, the piece is 4 5/8 wide. I go a 1/16, then 4.5 and another 1/16, so that these lines represent the finished long points on either side of the piece. And I'll slip that in the vise and draw these angles on here so you can see what I mean. Turn it around so I can see what I'm doing. I'm using a super accurate Starrett tri-square here. I'm able to line up a 45-degree angle line with the pencil line on either side. So I know that when I make the final pass on those bevels, I'll end up with the exact width I want from long point to long point. And because I want super tight miter joints when I glue these box newels together, I want the final pass to that pencil mark to be made with a joiner, not with a table saw. So I'll add 2 more lines on these pieces that connect at a 1/16 of an inch up from the face on the sides. Probably makes more sense looking at it than talking about it. Those lines are like so. So what I got is the exact final width of the piece from that mark to this one, and the 45-degree lines that correspond to those, and then another 45-degree line that goes 1/16 of an inch up on either side. I hope that all shows up good on the video. And now back at the table saw, you see this is a piece that I already cut. But this is a piece, I just put those layout marks on, and the saw blade lines up with the outside pencil mark. It's just taking the pencil mark on the face, and you can see it here on the edge. So when I run the piece through this way, turn it around and run it this way, I'll have 45-degree cuts with that extra 1/16 of an inch of wood on either side. That allows me to get consistently parallel cuts with a 45-degree cut on both sides. Like I said earlier, if I try to cut this with the saw down till there's a razor sharp corner on there and then feed it along, that corner is going to slip under the rip fence and make the pieces inaccurate. I recently did a video about making these handle style push sticks with some explanation as to why I like these versus the kind that are long skinny sticks. And this is a perfect illustration why I prefer this style of push stick. You saw in the other video when I made this cove cut in there, the face of the piece has to be down on this setup to make an accurate cut with this table saw. Granted, it's a right tilt instead of a left tilt, but if I had left tilt, I'd just reverse the whole setup. The face would still be down on the table. And with this bevel cut, if I was to use one of those twiggy push sticks and push, this piece is going to want to tip up because the pressure from that little push stick pushes on the end of the board. With this style of push stick, I could put pressure on the face of it and still hook this back with the heel and shove it safely through the table saw. In that video, I also covered the way to make a handle forward style of the same push stick. And this is an instance where that handle forward style worked really well. These long pieces with coves on both ends, I left them long so I can make these miter cuts on half as many pieces. They're twice as long, a little easier to handle. But while pushing these guys through the table saw, it's nice to have this handle forward version, putting pressure way up here, and I can feed the whole thing through accurately without worrying about it tipping on the way in or tipping on the way out. And I will endeavor to put a link to the push stick video at the end of this one, so you can check that out if you haven't seen it already. So once all the pieces are ripped to an exact consistent width with parallel edges, and I've done this layout and set the saw blade, it's a matter of just ripping this bevel on both sides of all the blanks. And this push stick rests right there on the rip fence for quick draw capability. And now you can see how there's a small flat spot on each side of each piece, and there's still extra to trim off. And I'll set the joiner up to make a final pass on either side of all these blanks now that the edges are all bevel cut on the table saw. I wanted to show that scenario on one of the actual pieces, but I made these sample blocks. They're the same width as the real pieces, but I'll have this available to set the joiner up to get this to end up at exactly 4.5 inches without risking any of the final pieces that I need for the project. And now I'll rip the last few blanks for the cuffs on these newels. Notice how as I'm pushing the pieces through, especially the shorter ones, I've got the push stick to this side of the piece. And I'm pushing in and towards the fence as I go through. I don't want to have the push stick over here where this piece could get caught and come out at an angle like that. And because it's a push stick, I can put it right over there next to it. If that blade happens to nick the push stick, it's no big deal. That's what it lives for. I gotta say, there's a few perks to having a wood shop in the garage and a wood burning stove for heating the house. The first perk is you get to burn designer firewood. What do you think coved kindling is worth, huh? I probably shouldn't even mention the second perk, but any mistakes I make go up in smoke and nobody's the wiser. All right, all the red and blue lights quit blinking. I think we're live and in color. With all these pieces cut with the bevel, it's time to run them through the joiner for their final pass on the miters and the final width on the pieces. And I've got these 2 sample pieces of scrap. They're cut just like the final pieces. And I put these margin marks on here to show about how much needs to be planed off to end up with the final piece. I'm going to take it over to the joiner for that part. As much as I love this PJ 882 joiner, I'll have to say that the fence angle setting thing is pretty lame, and I think of it more as a range finder than as an actual gauge for the angle setting. So to do this, I always cut a piece on a miter saw to the angle I'm looking for, in this case exactly 45 degrees, rather than rely on this veneer and this gauge, because that's nowhere near accurate enough for this sort of work. And I can unlock the fence and dial it down. And I always prefer to put the workpiece for a sharp angle like this into the fence so I can push it back into the notch rather than tilt the fence the other way and have this piece wanting to slide around and not hold the true 45-degree angle. It's going to be tricky to get this angle shot in the camera, but I think you'll get the idea. I just lay the flat edge of this on the table and then turn the crank until the fence meets up with that block. That's a little too far. That's not far enough. I'm going to dial it right in there and then use the lock arm to lock this down. And I've added a stop bolt in here. There's a hole in this piece of the fence apparatus. Has a threaded hole for a 5/16 16 bolt, and I threaded that down in to the point where the tip of that bolt is resting against the back of the fence. Because of the flat angles of all these parts, this fence will flop around without that extra bolt in there. And every manufacturer's fence setup is going to be a little bit different. The fence will probably have its peculiarities, but just make sure that the fence is rock solid in the setup and dead on for accurate, because any inaccuracy in the miter gluing up these box newels is going to multiply itself around. If it's a little too much or a little too weak, there's going to be issues later on. So it's key to spend the time getting this set up rock solid and spot on. So once the fence is all set up, and I've got it set this direction a good ways so there's not a lot of exposed cutter head under the guard, and then I'll take the scrap setup piece, and I want to set it up so the joiner is set where I can take one pass on each edge of all the blanks and have them end up exactly 4.5 inches wide from long point to long point. And like so many other setups, I will just sneak up on it until I get it dialed. But my first pass is going to be to get the cut right into that pencil mark. With that first test run, I'm at almost 4 5/8 still. So that's not quite deep enough. I'll lower the cut by half the amount that needs to go narrower, so just about another 1/16 of an inch. And then I'll run that test on a second scrap. And because I only have one test piece left and I need to run the cut from each end, I'm just going to gauge this out. And it looks like my adjustment is probably going to be a little bit too much. So I'll raise it back up again and finish this up and hope for the best. And I'm liking that final pass. I'm at 4.5 and just a fuzz strong, about a 32nd. And I'd rather have it just a little big than a little small, so I'm going with that. You can see with this angle of the light, this is where the cut was too deep and it transitioned to the right depth of cut at that point on both sides. Doing this process in 2 steps, one with the table saw for a rough cut and then a finished pass with the joiner, increases the level of accuracy on the finished parts. And I do it that way, as opposed to just taking off a huge pass with the joiner in the first place, going from a square edge all the way down to the 45. And this machine can do that, but it introduces too many opportunities for inaccuracies in the process. And here I stop a piece partway through its pass so you can see the material that the joiner is taking off. It makes the surface perfectly smooth for gluing, and it removes the 1/16 inch wide flat edge that helped cut the pieces to a 45 in the first place. And I make sure that I do every single piece that's going to be needed along with the spares while the joiner is set up this way, because having to repeat and match the process is time consuming when dialing in this level of accuracy. It's absolutely essential that this whole setup stays locked down and that the pieces continue to come off the joiner exactly the same as the section of the pattern piece that the setup was made with. If something gets bumped or moved, I always have this one to refer back to, and a lot of times I'll check partway through the process just to make sure something didn't change that I didn't notice. Well, all these pieces are now jointed down to their final size, and I can cut the doubles in half and get ready to glue them up into the final box newel setup, which will look about like that. A final comment about using the joiner for making the final pass on these. Normally a pass on a joiner is just for flattening or straightening an edge, and you can take multiple passes till the edge is the way you want it. But in this case, the depth of the cut determines the width of this piece. So I've got to make sure every pass through is right the first time, because I get one chance on each side. If I have to take a half a pass again, or if I get a chip of shaving or a sawdust under there and it turns this, run it through, it's going to distort something. So using the joiner for final sizing of a piece is a different operation. It's more like a table saw operation where you set a dimension and make a cut. In this case, we're setting the dimension with the depth of cut and making the pass as the cut, so that the cutters on the joiner are making the final pass, not the teeth on the saw blade. And that's just because I want this glass smooth and flat finish for glue up. All this is possible using just a table saw, and the joints will probably be plenty strong enough if it's a good sharp blade and it's not wobbling, but it's always going to come out better using a joiner for that operation. So the next thing I'll do is cut the doubles in half and start gluing these up for the final base and top pieces for the box newels. Well, I'm working my way through this batch of parts that are all coved and mitered and gluing everything up using these Merly clamps that are absolutely indispensable for this kind of an operation. I've got the taller waist sections of these newel posts, a tall cove section on the bottom, a waist section in the middle, and then the shorter cove pieces will go on top, like so. I've done myself a carpenter's favor by making these pieces just random length, and then I glue them up with one side all nice and flush, and then I trim this side off later to have it come out the exact length. I did the same for these waist sections. They're kind of even on one end and they're way off on the other end. Same for these. That way I only have to pay attention to the four corners and one end. I don't have to make sure everything lines up so much. You got to make it easier on yourself because nobody else is going to, right? And I went through the glue up process on that taller waist section, but I wanted to show you how it looks doing these shorter ones. Just one clamp is involved, and I need to make sure one end lines up accurately. So that's what this segment's going to be about. Gluing up these two different length cove sections is the same thing, only different than gluing up these tall waist sections. So I'll go through the process for one of these and glue up this batch of short pieces for another one of these top cove sections to show you the process. You can see what's the same and what's different. So I went through all the short cove pieces and worked out the grain match just like I did on the longer pieces for the waist sections. And for these parts I want the coved end to line up perfectly in the clamping process. So I'm just putting them up against the rip fence, and again I will overlap the miters just ever so slightly. And because these are so small, I'll use one Merly clamp but two pieces of tape. I want to make sure that's pressed down good, everything's overlapping just a little bit, and add that second strip of tape. Press everything down good, and then I can just take these pieces to the Formica table for glue up. And because I'm using that good 3M masking tape, everything stays together. I can just roll this thing over. I want to make sure I get glue right out to the edge of that coved section. I don't want any gappy glue joints in that important part of these pieces. But I've got good glue layer everywhere. press the joint together and pull it apart, make sure everything's looking good. If you use inferior masking tape, when you go to push this stuff together, it just tears at the corners because of the overlap part. Got a few crumbs from cutting those pieces in there. I want to make sure it's out so they don't hold the joint open. And that's about all it takes, but I did forget to shuffle this end. I want to make sure all these ends are nice and flush, and that last joint was misaligned by a little bit. I can slide it back and forth like this a little bit. There's a little bit of play in everything. I just want to make sure that that's lined up when I pull that tape around for the final side. Now everything's nice and flush. Get the bulk of the glue off the table so I don't goober up those Merly clamps. And I lay this so this tightening handle's up, not down. Makes everything a little easier. Just kind of wiggle these jaws into place. For as many wiggly moving parts as there are on these clamps, I am absolutely amazed that you can even manage them at all. It doesn't take long to shovel that clamp into place. I'm going to wiggle it down part way, add a little tension on the clamp. And while using these, I've noticed that these clamps can slide a little bit on the miters, and it's still got these little pivoting jaws on there. But the closer those clamps are to square with the corner, the more even the clamping pressure. If I shift one of these and tighten the clamp, it tends to make these clamp up in a parallelogram instead of a square. And then I get everything lined up and just put the clamp pressure to it. You can see all the glue squeezing out on the inside. I already know that the outside corners are full, and as long as the sharp points of those miters are lined up, puts me in real good shape. I double check this end is still nice and flush, which is the most important part because this end gets trimmed off later. You can pull the masking tape off to get it out of the way. But I got this one under the clamp. I'm just going to leave it. Won't hurt anything. I'll take it off later, but at this stage I want to make sure that everything's clamping up nice and square. And that's going to be this right on, so it's perfectly square all the way around, and one end is flush. I've got my little scraping wand here. It's like fingers on a chalkboard there. So like I said, on the longer sections, that glue on those inside corners could arguably make these glue ups stronger. I'm taking it out of there just to keep things clean and neat. I can do a quick bit of preliminary glue cleanup here while it's still wet. Even though it's difficult working on a relatively small piece with such a big clamp, I can get the bulk of it off while it's still pliable. And that's pretty much the glue up process for these smaller pieces. And once everything's glued up and clamped, I'll trim them all to the same length with the same setup. And even though I clean this stuff up, when I clamp it, scraping in between the clamps, etc., there's always going to be a little bit of residual glue on these, but it's cleaned up real easily because it's so minimal by using a sharpened putty knife. And this is a place that I absolutely do not want to use sandpaper for cleaning this up because it just makes that glue all gummy, and the heat wants to push it down into the wood and clog the sandpaper. And I don't want to dull these corners yet. They're still quite sharp after the glue up because the joints were all made with the final pass on the joiner. This method works just wonderfully for perfect cleanup on this sort of thing. And if I tried, I could probably cut my thumb on those corners. Got super tight miters, strong as can be. This end is all nice and flush. I'll have to sand it on a flat surface before assembly to get the sawtooth marks out of those flat surfaces, but that's about it. And in case any discussion comes up about the strength of a glued up 45-degree angle with no biscuits and no lock miter, I'm just going to take this cutoff from one of the columns. Let's put it in a vise and see what kind of strength this thing has all by itself. And I think that pretty much explains it. It's the wood itself that's failing in this sort of test, not any of the glue joints. And this is just a short scrap. So you can imagine the corresponding strength of a full-length tube or any of these coved collar sections. That's where careful setup and accurate machining really makes a difference in the quality of the finished product. Well, I guess that's that. Professional joinery for exceptional results on these cove sections for the box newel project. These parts are obviously specific to the project that I'm working on, but I hope you can see how this methodic process can be adapted when you want professional results like this on projects you're doing. I guess it's just against my nature to whittle a video like this down to 10 minutes of clickbait, so I really appreciate the time you invest by watching it. When I consider trimming out things like the process for dialing in the joiner fence accurately enough to get the results I'm showing, I always think, man, I wish somebody had shown me that trick somewhere along the way. And then I just leave it in. And from what I hear, that's the kind of mindset that separates the 15,000 subscriber woodworking channels from the 100,000 subscriber super channels. But I'm not going to let that change my primary mission here, which is to help aspiring carpenters take their skills to the next level and beyond. I hope everyone knows how much I appreciate it when you watch a video, give a thumbs up, add a like, add a comment, and subscribe. When it comes right down to it, it's that kind of buzz that provides the energy that's making this channel grow. So I'll keep striving to improve the quality and frequency of video uploads as long as viewers like you find it beneficial. And I'm really excited to see where this whole thing leads. So for now, to viewers and friends all over the world, thanks for watching.